Alright, hey, hello everyone. This video is basically just a recording of the workflow I did to achieve the result of the scanned radiator. So the first software I use is Kinect Fusion, which comes free with the Kinect SDK. And this is basically the cheapest option available that gives the best results. I mean, you can look at packages such as Reconstruct Me, but for a free best result, I found this to be the best. So I've just captured this radiator in my room, and I've just gone and exported that as an OBJ. Now the next software, if you've not heard of it, is Meshlab, and this is mainly used for point cloud data or 3D scans, and it's really useful for cleaning up the mesh. And what I'm going to be doing here is isolating the scan just to the area I want. So just to go a quick overview of what I want to achieve with these experiments and videos is I just want to share my findings, my experiments with using the Kinect as a tool to generate geometry and bake normals and AO from the scanned geometry, and generally see if there's any potential for the Kinect. From what I've seen is we've seen a lot of scan your head with the Kinect and then 3D print it, or use the Kinect as a sensor for your robot, or very low key things. And I kind of wanted to take that one step further. I mean, it's the amount of things the researchers have been doing with unlocking the Kinect is really great. It's amazing, but I found that no one's really devised a workflow or said, look, this is how you can use the Kinect to do X, Y, and Z. And I mean, I guess it could be fairly self-explanatory, and we'll work it out yourself. But no one's really gone out of their way to explore whether or not the Kinect is useful. And yeah, so that's kind of what I want to achieve with these tests. So what I've done is in Meshlab, it's good. It has a good way of working with high poly counts. So I was able to quickly select the vertices and delete around the area I wanted. Here I'm now going to do further cleanup. When it came in, it was about 900,000 vertices or something like that. As you can see at the bottom there, now down to 40,000. Now I've just gone in and done some basic cleanup where I've duplicated all the removed all the duplicate vertices, and that's pretty much. I mean, it's a bit of a nasty cleanup, but you could take this further. You could go further and try and achieve the best results possible. But if you're doing this really quickly, it just goes to show how quickly you can get a ready mesh to bake from. So I've now gone and taken this into Maya, and yes, the scan comes in incredibly small. And I just go here and set it up for a basic planar bake. So I'll just be baking this scan mesh to a plane. And so yeah, this is the first test. Essentially, this test was to rule out. Just do some basic smoothing here to try and further iron out those bumps. But again, you would have to spend a little bit more time cleaning up, and it's kind of a payoff. Do you just quickly scan a mesh, or is it more worthwhile to do it by hand? Again, this is the whole point of this test and these experiments, is to just generally rule out whether or not it's useful. Perhaps open it up to debate. Maybe from this, someone else might want to explore the potential of using Kinect to make game models. I just kind of want to see it more predominant, perhaps in the community. And yeah. Okay, so almost got the bake planar set up here, and I will just proceed to export it to X normals and proceed with the bake. So I was going to say so this is the first experiment, and for this experiment, the hypothesis was purely can you scan a hard surface and retain, bake normal details from it? And the off the bat answer is, well, yes, you can. If you see if you observe later when the bake starts, it works fine, and it would make sense. All the face normals are facing the right way. Even though it's noisy, it still is able to, render out the details and all those bits. So, yeah, it was a successful experiment. However, this is where I want to open it up to get the voice of the masses. Basically, it's now arguably debating whether or not something like this would be useful in say like an independent or freelancer art workflow, and given the fact that it isn't the cleanest mesh, there are other potential uses that I've been thinking of. Say for reference, this could be a great way to generate not reference mesh. Instead of having, say, image planes, you could just quickly do a really dirty scan and then use that, and you've got even the depth values and things like that, and that could be incredibly useful, especially for the artist starting out, and that would help with learning. My brain's not working today. Especially help with learning proportion and things like that. So that's pretty much it for this video. If you wish to watch the next 3 minutes of the AO baking, you can be more than welcome. And generally, I just want to say that this is just a very basic demonstration of how the Kinect could be used, and it essentially does well. If anyone knows of anyone else who's done this, please let me know, because I couldn't find anything specific to games, because the thing that I'm looking at is specifically, does the Kinect have application in game art production? Yes, there's been a plethora of articles and research papers into scanning heads and 3D printing them and things like that, but it's specifically, can the Kinect be used in game art production? Is there application for it? Is there a way we can weave it into a workflow? And I just want to say again, that is the goal of this research. Is I will be experimenting with potential applications, making these videos, sharing it with the community, and hopefully from that people will begin to see this. Like with all things, the community will either take it or leave it, type thing. But hopefully it'll be interesting to see what this sparks. And again, thank you for watching, and that's all from me. In the next video, I'll be looking at scanning cloth, and that will be a bit more interesting. My hypothesis for that experiment is that it will work, but there could be some potential flaws again. But that again will be explored, and I will have a video showing the entirety of my workflow. And thank you again for anyone who does participate in the debate. I'm very thankful for my research paper, and yep, thank you.